Hello! In this video, we're going to solve an example problem related to relative motion. So let's take a look into this example here. We have a boat that takes 1 hour to go down 60 kilometers in a river. It then goes up the same path, but now it takes 2 hours. Let's assume that the engines of the boat are kept at constant power during both ways. So let's determine the velocity of the boat in relation to the river, the velocity of the water in relation to the riverbanks, and the time it takes for the boat to go down the same way but with the engines off. So we know that the velocity of the boat in relation to the riverbanks equals the velocity of the boat in relation to the water plus the velocity of the water in relation to the riverbanks. So to make things a little bit easier, let's think into this drawing here. We know that when the boat goes down the river, the velocity of the boat in relation to the water and the velocity of the water in relation to the riverbanks are in the same direction. So we have the velocity of the boat plus the velocity of the water. If you think using the same logic in the opposite way, well, now the velocity of the boat is on the opposite direction of the velocity of the water. So we subtract these two velocities, and in the first case we add the two velocities. Okay, so let's start answering letters A and B of the problem. The velocity of the boat in relation to the river and the velocity of the water in relation to the riverbanks. So we know that when the boat goes down, we can add the velocity of the boat and the velocity of the water. In this case here, both velocities equals the variation in space divided by the variation in time. So we have 60 kilometers per hour. We also know that when the boat goes up, we subtract both velocities. So it's the velocity of the boat minus the velocity of the water. In this case here, we have 60 kilometers in 2 hours, so we have 30 kilometers per hour. We have then two equations and two variables. So solving the equation system, we have starting from equation 1, we can isolate the velocity of the boat and then add this in equation number 2. Doing this, we can find the velocity of the water. Again, we take this velocity and add in equation number 1, so we have velocity of the boat. So velocity of the boat is 45 kilometers per hour, and velocity of the water is 15 kilometers per hour. Velocity of the boat is the same as the velocity of the boat in relation to the river or the water, and the velocity of the water is the same as the velocity of the water in relation to the riverbanks. Now for letter C, the times it takes for the boat to go down the same way but with the engines off. We know that, well, when the engines are off, the boat will move in the same velocity of the water in relation to the riverbanks. And we know this velocity already. So we have that the time is the 60 kilometers divided by the 15 kilometers per hour, which gives us 4 hours. Alright, now it's your turn. So imagine this scenario here. We have car A going 40 miles per hour. We have car B going 60 miles per hour in the opposite direction. And we have car C going the same direction as car A, but at 100 miles per hour. So can you tell me what is the velocity of B in relation to A, the velocity of C in relation to B, and the velocity of A in relation to C. So you can comment down below your answers, and that's it for today.
Now that you understand the basics, we can cover even more advanced topics. Like this video and let's move on to the next one.